Hey guys, I want to go over another one of these. I know in class today we didn't have a chance to kind of finish, so I'm going to go over this problem, which is the first one on tonight's homework, just so you have a chance to kind of see this in action. I'm going to move this down so it's here, and the first thing I'm going to do is I'm going to make the never eat soggy waffles or never stop eating waffles is a way to think about this table, which is how I taught it in the video. And we have two vectors. We have vector A and vector B. So I'm going to call this vector 1 and just vector 2. It doesn't matter. You could use A and B. But there's vector 1, there's vector 2, and then we're going to do our total vector. Remember, the end result is to figure out if we went in this direction and then in this direction, where would we end up from our starting point, right? Essentially, we're doing this, and then we're doing this. We're trying to find this, right? And so that's really the big picture. That's all we're doing, and it's a little bit of math, but it's not too bad if you have your calculator. So hopefully you have a calculator with sine, cosine, and tangent, and we're going to go through this. So if we look at the first vector here. This vector is going due west. So my vector 1 has no direction in the north, none in the south, none in the east, and we'll do this in blue. So it's got 60 meters to the west. That's it. That's vector 1. Vector 2, if I look at this, is going southwest, right? Which tells me that I know in the north and in the east direction, it's going to have a magnitude of 0 as well. So then I need to find what is its south direction and what is its west direction. So what I'm going to do here is I'm going to zoom in on this vector, and we're going to draw, we know it has a south component, so I'm going to draw that with the correct tip pointing in the correct direction, and then to the tail of that one I'm going to draw the west vector, right? These are our two components, and this is 45 degrees south of west, which means, right here is west, so that means this angle is 45 degrees. Well, if that angle is 45 degrees, then this angle has to be 45 degrees. Remember, this is a 90, right here, this makes a 90-degree angle. So these two angles have to add up to 90. So if that's 45, I can do 90 minus 45, and I get this angle is 45. Okay, so we now know that this vector, let's do this. This vector is 30 meters long, okay, and this angle is 45 degrees. So if we think of our triangle using this angle, this is our adjacent side and this is our opposite side, okay? This is our hypotenuse here. So I'm going to start and I want to find the opposite side. So using this angle, remember, SOHCAHTOA, we really just need SO and KA. Sine is opposite divided by hypotenuse. Okay? So if I take the sine of 45, that equals O, which we don't know, divided by H, which we do know, which is 30 meters. So now on my calculator, I'm going to type in sine of 45 and I'm going to get a number. That number is going to come out to 0.707, and that equals O divided by 30. So then I'm going to multiply to get O by itself to find out what this opposite side is. I'm going to multiply 30 to this side. So I'm going to multiply actually both sides by 30. So I'm going to multiply this side by 30, and the 30s cancel out, and I'm going to multiply this side by 30. So now I do 30 times 0.707, and when I do that, I get an answer. The opposite side is 21.21 meters. So if I zoom out, if I zoom this out, I just found that the x component for this, which is west, right, it's heading to the west, is 21.21 meters. Okay, I could do the same thing for the adjacent side here, right? I'm not going to zoom in here. I'm just going to do the math over here. I can say, oh, cosine of 45 equals adjacent over 30. Well, it turns out the cosine of 45 is also 0.707. So that equals A divided by 30. So then I multiply both sides by 30 here, and I get A equals 21.1. Well, my A, that's this side, that's going south. So for vector 2, that's 21.21. Okay? And now actually this is going to work like this. What's my total vectors now? What's my total in the north direction? Well, that's going to be 0, right? What's my total in the south direction? South is 21.21. Put a little box around that, since that's going to be useful. East is 0. And then west here is 81.21 meters, okay? Okay, so all that means is at the end of the day, I've got the total southward component of these two vectors together, or we can call this CY, is 21.21 south. So what I'm going to do here is I know I'm going to have a south vector of 21.21. I'm going to have a west vector of 81.21. Now I want to add vectors tip to tail. So here's the tip of my south vector, my combined south vector, and if I take my combined west vector, we'll do that in blue, and add it tip to tail, right? So there's the tip, and there's the tail. This is 81.21 meters west. I now can find this resultant. I want to find this angle here. So first of all, how do I find the hypotenuse? Well, I've got two sides of a right triangle, right? Here's the right angle. So this is a right triangle. So I'm going to use the Pythagorean theorem. And when I do the Pythagorean theorem here, right, I'm going to take this squared, 21.21 squared plus 81, so it's going to be 21.2 squared plus 81.21 squared. I'm going to do that in the calculator. I'm going to get a number, which comes out to 7044, and I want to take the square root of that. That number comes out to 84 meters. So that's my answer here. This is 84 meters. And then to find this angle, I can use tangent to find the angle. And the angle, the answer comes out to 85 degrees. Okay, so practice that one. Let me know if you have any questions. Okay, so you can't hear any noises in the background, but now you found the hypotenuse. By doing a squared plus b squared equals c squared, we get our c squared of 84. We now want to find this angle. So we're going to apply tangent. So remember, SOHCAHTOA we use a lot. What do we use TOA for? Well, it turns out TOA is opposite over adjacent. And hey, look what we have. We have the opposite side and we have the adjacent side. So what we're going to do is we're going to do inverse tangent, right? Tangent inverse of 81.2 divided by 21.21. So 81.2 divided by 21.1. And that will give us an angle of 85 degrees. And if you look at our vector here, this is south. So the resultant is 85 degrees west of south. Okay? So hopefully that makes sense. If not, we will spend a lot of time in class over the next 2 days making sure that everybody understands how to add these vectors up. Awesome. Have fun.